Hello, my name is Oliver Mace and I manage the Design and Development Department at Ecorol. Today, I would like to show you in this video how you can implement and realize a construction that meets the requirements using the fixed rolling process. Many different requirements are placed on technical products. As designers, we certainly all know this tension triangle. In our component design, we are always faced with the need to choose between the three poles of cost, process efficiency, and quality. It is always necessary to ensure that all three elements are as balanced as possible, and if we strengthen one, the other will usually become a little bit smaller. In this tension triangle, we always have to move. Unfortunately, or fortunately, another pole is added to the equation. The topic of sustainability is becoming more and more important, even in the construction industry. We have spent a lot of time discussing whether a component needs to be efficient in terms of production, CO2 efficiency, and whether a component needs to be efficient during the use phase. We have already created a training video regarding this and also showcased it on the channel. The topic of construction is always a central component. In the construction, we define the carbon footprint of a component throughout its entire life cycle. We define here how efficiently a component can be operated and utilized, and that also defines how much CO2 a component emits. A multitude of diverse requirements are placed on technical products. I simply brought a concise list here, which is of particular interest and relevance for our specific area at the present time. The weight of the building block is crucial and plays an important role in a different context. More specifically, in the tension that arises when trying to balance the objectives of sustainability and security. Of course, we can always make a component incredibly safe. We can drive the security incredibly high. We can design it to be permanently stable by simply making it very, very thick and massive. But this means that the component is not very sustainable, that the resource efficiency of this component is quite low. So we have to design and enable the component to be very light, with very little use of material. This often comes at the expense of security. So as designers, we are operating in a really complex field of tension here. It actually becomes a little more complicated, it becomes a little more difficult when we want to exert influence on that, when we incorporate the topic of manufacturing tolerances, manufacturing qualities. We consistently encounter disparities in production. A component will never look exactly the same and possess the exact properties as we have meticulously planned in the computer-aided design CAD software. This implies that we need to consider the manufacturing tolerances in the processes. We need to design the component more robustly because we are aware that the notch effect may be slightly larger than it is supposed to be. One tool that we designers have had for a considerable number of years is the Wöhler line, or the Wöhler curve. The Wöhler curve shows the relationship between the load applied and the maximum number of cycles that a material can withstand. This implies that we plot the number of load cycles on the x-axis and the load on the component on the y-axis to analyze the relationship between them. This illustration demonstrates the typical pattern commonly observed in the progression of a Wöhler curve. With an increasing number of load cycles, I am able to apply less stress to my component. We can all imagine that very well. What is the point I'm actually trying to make here all the time? I want to point out that if we want to interpret something in a load-appropriate way, and if we want to interpret something sustainably, without much waste, with as little material input as possible, then we have to ensure that we get the area of endurance strength as high as possible. And that's exactly what we see in every Wöhler curve when we compare a solidified component with a non-solidified component. The same applies to components that have been shot blasted or components that have been machine surface hammered. All these processes of mechanical surface treatment ensure that, especially in the area of endurance strength, the load to be sustained by a component is significantly increased. That's the end of this video. I would like to thank you very much for your attention, and if you have any questions or comments, please do not hesitate to contact me or my colleagues at Ecorol AG.